programming. Let's start. So I will be talking about Spring Cloud Contract, and about contracts in general, and when they can be useful, and what problems they're trying to resolve, and also some architecture improvements that we can get out of using them. My name is Olga Maciaszek-Sharma. I work in the Spring Cloud team in Pivotal, but I have worked on Spring Cloud Contract for much longer. I started working on it when it was still called Accurest and was a small library that Marcin Grzeszczak and Kuba Kubryński started working on in free time. And then it has grown, people started using it, and so it was moved to Spring. So one of the problems that Spring Cloud Contract attempts to solve is problem of removing some or even the majority of the end-to-end tests that we had. And why do we want to remove them? So this problem is a known problem, and even with the monolith, we knew that it was not a good thing to have a lot of end-to-end UI-level tests. That's a slide from Venkat Subramaniam's presentation, and probably many of you agree with this. I do remember pipelines that had tests that went for hours on end to finish in a failure that very often resulted from a flaky environment and not from the real development problem. So we always knew that was bad. We always knew we should have a lot of unit tests, then some less integration tests, and then only end-to-end tests for the critical scenarios. That's nothing new, that's the test pyramid. However, people still kept using it extensively, and people kept relying on end-to-end tests for their monoliths apps. But when they wanted to switch to microservices, that approach, which was bad in the beginning and was not good anyway, but was still possible to apply and sort of to be sure that everything's working because we have tested all the user scenarios, even though it was inefficient and slow and so on, that became completely impossible to maintain. So we have to reduce end-to-end tests very greatly when we move to microservices. Why is that? First of all, we have the environment problem. So before we had our monolith, we tested it. It was in the environment. Still, some things usually went wrong, but at least there was one piece of software to concentrate on during deployment. Now, we have many collaborators. So every app is doing requests or listening to messages from many other apps, and we have to have this whole environment deployed. And this means that, for example, if some other team is working on another app and will introduce changes and can break something, can redeploy, can restart their service, in production we will want to have zero downtime deployments, but it not often happens in test environments. So most often this test environment, which was flaky to begin with the monolith, with microservices, will become extremely unstable. So we cannot afford that. And another solution could be having one environment per service. So let's say I want to deploy service A. I have a pipeline for service A. I have a test environment, and there I deploy the service A and all of its collaborators. And I can test everything. Why not? What's the problem with that? That is extremely costly, not only when it comes to the equipment and the virtual machines and the cloud payments, but it's extremely costly when it comes to developing and maintaining it. You will need a lot of people to maintain all these environments. And as we've said before, the one-to-rule-them-all method when we deploy everything to one environment is simply unstable and difficult to rely on. Another problem that we often forget about is deployment coupling. So we took our monolith, or we started with the microservices in the beginning, and we have this beautifully divided code bases. And we have small teams that know their code and that are able to develop independently and work on the changes independently. But if we do couple them on deployment levels, and if they will need to communicate with other apps during extensive tests before the deployments, and will depend on other versions and deployments of other apps to deploy their service to production, we are coupling the process. So we have decoupled the development part, but if our deployments are coupled, we still cannot leverage fully the gains that we could get from having microservices, because the whole point is not only to develop quickly and independently, but also to be able to deploy independently. Another issue related to this is the fail-safe versus safe-to-fail. So before, the approach that was very common was fail-safe. People thought we will test our code extensively. First unit test, then we will do extensive automated tests, then we will put a bunch of manual testers, they will work for 2 weeks. Once it's tested and then retested for regression, we will freeze this code for 2 weeks, and then we will deploy and our software will be bugs-free. The problem with this is that it is just a dream, because research shows that, extensive research shows that even the best tested code will always have bugs. So we deploy, we have bugs, but we are completely cemented when we want to fix anything. Our process is such that we will take a lot of time to, first of all, find where the bug was, because we have pushed so much code together. And second, we cannot push it to production fast, because we have all this testing and retesting and such. We can do a patch and sort of try to push it, skipping the process, but that's not the point. The point is to have, when you have these independent microservices and quick development and quick deployments, you want to be able to deploy extremely fast. So you want to have a pipeline that once you have merged your code to master, it will probably take a few minutes, maybe 10 minutes, maybe 15, depending on your company, maybe less. So again, you cannot have a long-lasting end-to-end suitcase. Another issue are circuit breakers. So very often, at least for the REST-based services, we will use circuit breakers to actually enable that our applications will not continue sending requests to their collaborators which are not responsive in any way, because it will replete our resources, and then it will be even worse impact on those applications. So we use Hystrix or Resilience4j. But the very important point here is that any good circuit breaker has a fallback. So it has a different method that will be run when the circuit closes, then when the circuit opens, and when we cannot do any requests. And what can happen with our test is that instead of testing the actual apps, we will test the fallbacks, and we will not even know that we are testing the fallbacks. So this, of course, can be architectured out, and the test can be written in a way to not to have this issue. But this is yet another concern to keep in mind. So how many end-to-end tests shall we keep? So some companies don't have any. They have extremely strong monitoring and response systems and canary deployments and so on. I have worked before for a company that had 2 of them, and that was enough. We didn't really have major fails. They tested the critical paths, and that was fine. Maybe in your company you need more of them. That's fine. What is important is that you need to keep in mind that you should test the most critical scenarios with those tests, not everything. And also what you need to keep in mind that for most end-to-end tests, they will start with the exact same path and only fork towards the end. So you want to avoid that. You want to think what is really critical and only test this. And for the rest, use other solutions. And what are the other solutions? So a very popular thing is stubbing. We can stub our environments, we can stub our tests. So of course, we do it extensively for unit tests, but we can also do it for integration tests, and we can do it in our test environment. For example, we can use WireMock. Has anybody used WireMock? OK, so for the people who have not used it, it is an in-memory Java-written HTTP server to which you will pass a JSON that describes your request. And when the server finds that this request matches the criteria, it will serve you a response that you have specified. So you specified, for this request, I want to get that response, and you get that. However, there is one problem. If we only use such solution, the problem is that we can be collaborating with another team on adding a new endpoint. So we meet them for a coffee, and we say, OK, we need to get this data from you. Can you add an endpoint X and serve us this data and status 200 when we make this request? And they will say, sure, we'll go, we will do it. OK, so I will write my WireMock stubs. I'm writing here that's my stub, and then I have a request, I have a get at endpoint X, and I want to get a status 200. But if we only depend on human communication, the problem is the human communication is not very reliable. And what can happen is that the other team has ended up introducing an endpoint Y, because they have changed their minds, they have forgotten to tell us, they have had some lapse in communication, and we never know. So we test with the first stub, and we are happy our tests pass, we know we can integrate with them, but when we deploy to a production when we have actual integration, and hopefully to an environment when we have full integration, and hopefully that's not our production, it will fail miserably. Of course, the same thing can happen with messaging. So we can expect a message that will deserialize to a certain POJO, in this case, a product, that will have a product ID, a product name, and will be sent to topic foo. But the other team, also, again, we can stub it, and we can mock it. There are lots of frameworks for messaging tests that allow us to stub the routes. So during the test, we just get what we expect. But the other team, the team of the service B or our producer, can in fact start sending the messages to topic bar. And what is even more common and more tricky, can be sending them to the right topic, but have different fields in the POJO. Even if the difference is very small, we will not be able to deserialize it. So the main problem here is that the stubs, the definitions of the stubs, the whole stubbing process lies with the consumer, and they have absolutely no way of guaranteeing that the producer app has really anything in common with that. That's like a wish list. So that's not something we want to have in engineering, depending on wishes and on coffee talks and thinking we are safe just because we think so. No, we want to check things. Another thing that can be a problem is even if we have the stub environment and everything is working and our stubs are perfect, the things can change. So with the public APIs, that will not happen that often, hopefully. But with internal APIs, people tend to switch them and even introduce breaking changes. And we will never know that this has happened, or we will know too late. So one solution to this problem is contracts. So a contract is a set of rules where we define, same as with the JSON. For this request, we want that response. But we not only define it during coffee talk, we codify it in a programming language. And then we also enforce that the contract is actually fulfilled. So I'm going to speak about contracts. I just want to quickly mention a few other things. Of course, if you want to greatly reduce your end-to-end tests, and if that's what you have been heavily relying on until then, you also have to have other safeguards. So you have to have a lot of unit tests. You have to have strong monitoring. You need to have alerting to know when something went bad. And you have to have good and extensive logging and be able to trace requests through your systems, through different apps. So if anything is bad, you can find the error. So given that you have all these things in place, you can now start to remove your end-to-end tests and switch them to contracts. So with a contract is an agreement that for an input A that the consumer requests, they will receive an output B from the producer. And a good approach to writing contracts is when the consumer has power to drive or to suggest changes in these contracts. Why? Very often what happens is that the team that is writing the API says, OK, we are the owner of this API. We will write it this way. We will give you these endpoints, and we will return you this data in this format, because that's easy for us. However, the team that will be really living with this API and using it and taking the consequences of how it's written is the consumer app team. So they should have a say in how this is written. And when the authors of Accurate started working with that, what happens is, what usually happens, that they had this new and bright idea, and then they checked out that Martin Fowler has already written about it a long time ago. So the idea is not new, but the implementation is quite new. And then the contract tests, again, you can read about it more in Martin Fowler's blogs. Contract test is the idea where we take our contract, but we don't only codify it, we actually test with automated tests that the contract is fulfilled. So Spring Cloud Contract is a solution that does exactly that. It will allow you to codify your contract, and then it will test automatically if this contract is fulfilled. If not, your build will fail. So there is a flow of how the authors imagined working with this framework. Of course, it can be modified if you have some reasons, like security reasons, where you cannot check out different repositories and so on. But the best flow is where we start with the consumer. So the consumer of the service B is checking out, cloning the repository of the producer. Why? Because they want to make a pull request. So they want to propose a contract. The contract will be kept with the producer to avoid the situation like we had before, that the consumer is defining and implementing the stubs and the rules. It has to be with the producer, but the consumer should be able to drive it and to implement it. So the consumer can write a contract and make a pull request to the producer. And this is a form of working together that we all know, so it's easy for us. So that is what a simple contract looks like. It's written in Groovy DSL. And again, it's similar to the JSON we've seen before, but it's easier to write because we will have auto-completion in the IDE. And this is Groovy DSL. We also allow YAML, and we have plans to add a Kotlin DSL as well. So you define, again, your request with your method, with the URL. You define whatever body you want. Of course, you can use regex because the actual numbers can change, and you define your headers. And then you write that in the response, you want a certain status, and you want a certain body, and also a certain set of headers. And this is the exact same contract, but just expressed in YAML. So what happens then? The producer team has received this pull request, and they can start working on it. And what will happen, first of all, they will run the build, and the test will fail. They have it on a branch. The tests are failing. They need to now implement the contract. And to do this, they also have to do some very simple build setup. For Gradle, it's just a few lines, like you see. In Maven, it's similar. It's very simple. You just need to add dependencies and set up your target test framework, in which framework you want the automated test to be generated. And you need to specify a base class for tests that will be used. All the tests will extend this class, the automatically generated tests, and there you can do some stubbing setup or whatever, or Spring context test setup, whatever setup you need for the test to pass. And this is a contract test. So the beauty of this test is that no one has written it. It is actually automatically generated by the framework. So when you have the contract during Gradle build or just Maven build, this kind of test will be created. And as you can see here, we verify all the things that were in the contracts. So we verify for the headers and the body. We write that when we have a message, a request with this header and this body, we actually do this exchange. Then we verify that whatever response we got has exactly the necessary fields in the right formats. And once that has been generated and the tests have passed, we also get the stubs. So these are the stubs that actually WireMock uses, but they are written for you out of the box. So with WireMock, you had to write this alone. And as we have the autocomplete, it's much easier to write it in Groovy DSL and just have this stub generated without having to actually write all these regular expressions in JSON. OK, so when we have the stubs and the implementation is there and the test pass on the producer, so when the producer's build passes, they can do what they usually do. They can deploy it to their Artifactory and then to production. And as they deploy the new version of the app to the artifact repository, the stubs will be automatically deployed along that app. So we will have two jars, one with the app and another one with the stubs, that will be used by the consumers to later download them, also automatically. I will show this to you in the code, and then run them, and then test against these stubs. But even though they will be testing against the stubs will be secure. They will actually reflect what is really in producer in production. Yeah, so now the consumer can start downloading and using these stubs. And for the consumer setup, it's even easier. It's just one dependency that we need to add, Spring Cloud Starter for contract stub runner. And when we add it, we have some functionalities that we can use. So first of all, we can use the auto-configure stub runner annotation. And this works similar to any Spring annotation. You can just pass the IDs of your stubs. And what are these IDs? These are just the group IDs and artifact IDs and the normal notation like you use in POM. And then you can pass a port under which you want these stubs to be served. And you can run your integration tests. And here we have a stub mode local. So it means that we are working still with the producer code locally. And then in our deployment pipeline, we should have the stubs mode remote, because we want to be using the actual stubs that have been tested and have been uploaded to the artifact repository, and we are sure of them. And here in this test, we can just use also, if we don't want to specify the port, instead we can use stub runner port annotation and just get the port like this. It will be randomly generated for us. And then again, if we don't want to pass all this in the annotation, we can pass it in the properties. So our artifact IDs and stubs mode and all the other properties that we have. And then we don't have to pass it in the annotation. And then if somebody is not using Spring, you can still use Spring Cloud Contract, because you can use a rule. So you can use a stub runner rule. And we now will also have a JUnit 5 extension. We are working on this. So it will also support JUnit 5. OK, let's see it on the demo. So this is a demo project. This is a very simple app that basically has an endpoint and is checking if the client that wants to take a loan is a fraud or not, and has a very simple service that has an if. It's, of course, only a demo code. But as you see, we have just commented it out to check what happens. So this is the implementation that should be there. And this is the implementation we check for in the contract. And we have these two contracts. So here, we have one contract where we pass a client with a certain ID and with a loan amount that is too high, higher than we want it to be. And we expect a rejection reason amount too high. And we have another contract where the amount is fine for us, and we expect an OK and a rejection reason null. So if we run it, let's see what happens. I'm running it with Gradle. Of course, we have done all the setup and added the dependencies. And as we can expect, the build fails. And if we see what failed is the contract verifier spec. Now, we have never written a contract verifier spec. How do we have it? If we see it's not in our tests, yeah, there's nothing here, but it's still in the code. So it is in the generated test sources in our build, because Spring Cloud Contract has generated it automatically for us. And it's verifying everything. And of course, since one of the conditions was not met because we removed our if, the test has failed. Now, if we just move it back to the way it should be, we expect it to pass. Let's see what happens. And now it passed. So, of course, this is a sample code, but you can imagine any kind of scenarios. The important thing to keep in mind here, however, is that during the contract tests, we will want to check the API. So we can make a base test class where we will stop some things because we don't want to be checking for the contract if our business logic is fine. We want to be checking if our API is in keeping with what the other side is expecting. So here we will stop many things, or we will use some test configuration for Spring, not the full context usually. And we will just verify the API. And then we should have another layer of tests that will verify our business logic. OK, so now let's see the consumer. So it is an app, which is, again, a demo app, very simple, doesn't do much. However, the one thing it does, it will actually consume the endpoint provided by the producer. So it will send requests using REST template to that application. And as we know, that application is not currently running. We have built it, we have deployed, we have created the stubs. The Spring Cloud contract has created them automatically for us, but the app is not running. We have not run a WireMock instance. We have not run anything. And we are just using this auto-configure stub runner that was on the slides, the annotation. We pass that this is our producer. We pass the IDs, and we have a normal test that would verify the communication. The same test could be run against a running producer app. And what happens? When we run the test, Spring Cloud contract will automatically launch an in-memory WireMock instance for us, and will set it all up. So when we were using WireMock, we had to do it on our own. Now it's done for us, and the tests pass, and we can be 100% sure that this API will really behave in the way we expect, because we have tested it. So the producer build would have failed if it was different. Going back to the presentation, let's see a messaging contract. So Spring Cloud contract will also apply to messages in a very similar fashion. We will have another contract. Here we will have to put a label. The label will be used for the consumer to know which methods they want to use, which route they want to stub. And then we will have from where the message should be sent, what will be the body, what would be the headers, and then we can expect an output message, or we can expect a different method to be triggered. As the result of it, we can all codify it again in the Groovy DSL or in YAML, and probably soon in Kotlin. And this is the test that has been created for us. So for this test, Spring Cloud contract uses contract verifier that will actually try to send this message and will try to trigger this message, and then will verify the output. So we can have either like here that we expect to get a message and then to respond with a message, or we can have a scenario when after a method is triggered, we expect to get a message. And this is the same test, just in Spock. And now if we see the demo, okay, I'm going to close this. These are, again, our sample messaging contracts. So here we have an app that is carrying out the payments, and either the payment has failed, and then it replies with failure after make failing payment method was triggered, or after make successful payment was triggered, the app should send a message with success. And when or how do we trigger these methods, that depends on our business logic. But once they're triggered, we are sending messages, and we want to make sure the messages are in the right format. So here again, we are using Spring Cloud Stream, and we are using source to output a simple message. So exactly the same thing will happen, but I just want to show you in the previous example we had Gradle. Now we can use Maven to do the same thing. And as you can see, it started the contract verifier test. Again, that is the test we have never written. Let's see this. This time we have a JUnit test. And of course, it fails, because the methods were triggered by the test. But as you can see, the test triggers the method. But the output message was not received in the right route. So of course, if we now get rid of the comment, it shall pass. Now what will happen is, here instead of the JSON stubs that were fine to use with WireMocks, Spring Cloud contract will output a definition for routing. And then when we use Spring Cloud Stream, Spring Integration, when we use these definitions, automatically our routes will be stubbed for us on the consumer side. So let's see it again. We have a simple consumer app, and this app is just expecting to get some input from the producer, and it's triggering by label, as we have seen the labels before, a given message. And then what we check that either the logic for successful payment was called or for failed payment. And again, we have not done anything. We have not set up any stubbing. We have not used any framework. It will be done automatically for us. So now we can run this test as though our producer app was actually running in production mode or just in our local environment. So another thing I would like to discuss is now certain things that we can use Spring Cloud contracts for in our architecture, and also certain things that we should probably avoid. One of the things we can do is using it for public API. Now we can think, we do not have a consumer that is going to run integration tests. We have a bunch of people writing things in Ruby or JavaScript, in Node. They're consuming our API. What can we do? We can still write a contract, first of all, to test ourselves that we are fulfilling a contract. Then, to be able to generate REST docs, which can be automatically generated from the contracts. And then, another thing is that we gain these stubs. And even though they're not going to use how to configure stub runner or even write a Java test with a rule, they can use a very simple method to run these stubs. So first of all, we can generate the Spring REST docs. And in the slides, I will leave the slides, and there will be links to all these things in the docs if you're interested. But then our consumers, if they only install Maven and add one dependency, they can run this command, and they will have the WireMock instance downloaded and launched for them and responding them with the stubs. So they can then do requests from Node app or whatever apps to this WireMock, serving them our stubs. Now, if they do not want to have Maven or Java or anything like this, because they just don't want it, they can still use Docker. So we provide in the Spring Cloud contract sites a Docker that will do exactly the same thing. So it will be downloaded, we'll raise a WireMock app, we'll load the stubs, and then they can do calls, and this Docker will be serving the stubs. Also, the Docker can be used for testing other apps written in other technologies as a producer, but that's a more complex topic. I am leaving links there, and you can check it out if you're interested. OK, so we can generate this REST docs from contract, and we can also go the other way around. So if we have REST docs, we can automatically generate contracts. And actually, to generate contracts from REST docs, if you already have REST docs, Spring REST docs, you only need to add one method call to your test that is generating the REST docs, and the contract will be generated for you. Another thing that people often ask about is OpenAPI. So even though we don't have a public plugin, there are community plugins that allow you, if you're using Swagger, let's say, and you have the Swagger file, to input your contract in that file, to keep everything in the same place. So this is also supported. Now, one thing that I would like to warn about, so the first thing was avoiding testing business logic in the contract test. That's a different layer that should be separate. Another thing is putting contracts for absolutely everything. So again, of course, we want to have much more contracts than we had end-to-end tests. That's obvious. But if we have a feature that is only being used once in a year, and if it's down for 3 hours, nobody will notice, and it doesn't bring any revenue to our company, maybe we don't want to write a contract. So we need to prioritize, write this first where it's really critical. Then if we see we actually like it, we are working with it, it's helping us, then let's write it for everything. Why not, if it's helpful? But let's start with essential things and not just start by deciding, now I'm going to write 15 contracts for every endpoint, for every possible input-output. We just want to verify if the API is working. Another thing is, if we have multiple values, we don't always have to write it for every single value. So we can have a failing, let's say, a scenario where we get 200, a 400, whatever scenario we want. But we don't have to have a scenario where we verify that we get a response 200 and then the name Jan, or the response 200 and then the name Pavel. This is business logic there. We don't want to test this layer. And same if we have, let's say, enums. So the enums very rarely change their form. Once an enum is there, it's very improbable that it will change. So instead of adding a new contract, what we can do is just replace the existing enum with the new value. So before we had a client type individual, now we also have a business client type. So we could add another contract. But the probability that this will change is very low. So we can probably just change the individual with the business and keep one contract. Yes. And now what we are gaining with contracts, apart from the obvious fact that we can now remove a lot of end-to-end tests and still be secure and have fast deployments, a very interesting aspect of this is that if you see, when the consumer clones the producer repo and then proposes a contract and pushes it with pull request, and then the producer will take it, will have failing tests, then they will pass, then maybe either the producer or the consumer will propose a change in this contract, or some other consumer that also wants to consume this API. So again, they're introducing a change, the test will fail, and then again we have them green. So we have the red-green refactor cycle that we know very well from TDD. And now we can use this methodology, which is proven, and many people like it while writing unit tests and while developing their apps and their classes and their functionalities. We can use it on architecture level. Another thing we can gain is being able to be sure that our APIs, even our internal APIs that we use within the company, because of course, again, for public APIs, we are usually more or less sure we are not introducing any breaking changes. But for our internal APIs, we can be sure that we are not breaking anything. And we know very well that even with a public API, probably if any of you integrated, I don't know, with another payment system, credit card system, whichever public API, and you got these docs, and how to write, and how to integrate, and what fields you will have, and what responses. And I've been in this situation at least 3 times. I'm sure many of you have been as well. You implement everything according to this documentation. You try it, and it fails because they have not updated the docs, because they were not using REST docs, they didn't have any kind of contracting things. So if it happens with the public API, it will sure happen with your internal API. And what you can check is check the compatibility. How? So when we have the deployment pipeline, now we have contracts, so the test will be automatically run against the contract. But what we can do is add in our Jenkins or whatever deployment pipeline we are using another step to check the contracts that are currently in production. And after we run our test against the new contracts, we also run our test against the production contracts. So like this, we know that for sure we are not only compatible with the new contracts, but we are also compatible with what we actually have in production. And then only we deploy to stage, to wherever. And if anyone is interested in this, it has been done in Spring Cloud pipelines. There are a series of scripts which allow you to set up the deployment pipeline in this way. So you can check it out, or you can write it yourself. It's not difficult. You just need to add one more step. Now, if we have this backwards compatibility check, does it mean in an internal API that we can never change anything? So, of course, again, with public API, we would use versioning. We would probably not want to change things at all. But in an internal API, maybe we do want to change something. Now, this is up to the company. Some would consider it a bad policy and not do it, and some would do it. I don't want to judge it. It's up to you. But what I want to tell you is that you can do it and still feel safe if you want to. So what we can do is use deferred updates. This is the same approach we use when we are changing database fields. What we can do is have our contract and our production app, and we have a build time field. And for whatever reason, the build time field was in seconds. And now we want to change it to milliseconds. So what can we do? We can add this new field with milliseconds to our contract, new version, and then to our production. It's running, it has both fields. If our consumer uses the old version, they can use it. If someone has started using the new one, they can use it as well. Now, and another step, we will remove it, but only from the contract. So we have the production running with both versions, but the new contract only has the new version. So now our consumers will check and will see that something has changed. Their tests are failing. They cannot integrate with this anymore. So what can be done? They have to adjust, and then once time has passed, once we know that our consumers have already deployed the new versions to production, we can remove the old field also from production. So I don't particularly recommend doing this kind of backwards and incompatible changes, but if you want to do it, make sure you do it safely. so that even though the field changes at any different point during this process, your app is safe and you're not breaking anything. Some time ago, I have written a blog post about more things related to this and how to use contracts and the architecture and what it allows to do. And I'm linking it in the presentation. And it's about how the contracts were used in a startup called DevSkiller, where I have worked. So if you're more interested in this topic, that goes more in depth through these things. And I am going to add the links to all the demos. And one more thing I would like to tell is what we are currently working on. So right now, what we want to do is we are introducing the support for web test client to support Flux and the reactive Spring framework, and actually be able to use this new stack also with Spring Cloud Contract. This is being done right now, and it should be released soon. Maybe not released, but definitely merged and then released with the next major release. And then what we are also working on, we have added JUnit 5 support for auto-generating tests. So the automatically generated test can be written in JUnit 5. And what we are also adding now is this extension for the consumer, so that the consumer will be able to use it same as the rule. So now already the consumer can use JUnit 5 using auto-configure stub runner annotation. But for non-Spring apps, we will also add an extension. And we also want to introduce better support for binary files. So that's what we are working on. And of course, this is a fully open source project. Everyone is welcome to not only use it, but to create issues and also to submit pull requests. Just make sure you contact us before, because maybe somebody's already working on it. But we are absolutely happy to have people file pull requests and file issues and discuss with us and ask us questions. And if you write to us on Gitter, but please read the docs first. But if you don't find a response in the docs, if you write to us on Gitter, we are definitely happy to help with any corner case scenarios or such. So that is all I have. If anyone has questions, I'm happy to take them.
Hi.
Hello.
So you were talking about testing basically with another tech stack. Let's suppose you have a Node.js application which is consuming APIs exposed by a Spring Boot application.
Yeah.
And you suggested using Docker containers. But in my opinion, it means so the build system in the front end has to deal with the life cycle of the container, basically. So the question is, what about publishing JSON stubs instead of, for example, jar files that can be easily consumed by a front end?
You can also use a version with having the stubs in the repository. So this can be done. And it's also described in documentation. You can have another repo and or even Git repo and keep the stubs there. But why we wanted to have the Docker is because most of the front-end people, they use Dockers anyway. And they like the technology. So before we had a jar, and the jar was for launching stub runners. So it does all the wire mock thing down there. Because if not, you have only stubs. And then they have to have wire mock or whatever other solution. And they have to launch it or even write something and launch the stubs. They only have the JSONs. And with the app, either with the Maven command or even if you have Java, you can use just Java jar. It's a standalone app that will take the stubs, raise a wire mock instance, and serve them. So of course, they can just get the stubs. But then it's up to them how they will automate the usage. We just provide the jar because, well, we don't know how to write an app in Node.js. We know how to write an app in Java, so we are serving it this way. But by all means, they can use, we can upload the stubs to a Git repo, and then they can take them from there and do whatever they want.
Thank you.
Thank you. Any other questions? If not, then I'm also happy to discuss anything after the presentation if you come to me. Okay, then thank you very much.